If you go to the movies and ask for a large helping of popcorn, you're going to get something like this. It's going to have about 10 cups of popcorn. It's going to have 1,200 calories. If you want butter, it's going to be 300 extra calories. Perhaps 3 days worth of saturated fats and more nutrition than you actually want for a long period of time. What's interesting is that a lot of people who get popcorn of a very large size don't actually want to eat all of it. And if you caught them separately and ask them, do you really want to eat 10 cups of popcorn? They'd say no. But the point is, a lot of them do eat all of the popcorn. Here's a simple thought experiment. If the same quantity of popcorn now came in 4 separate bags, would you eat as much? And the answer is no. And the answer is no because of a phenomenon that we call a theory of decision points. Let's think about it as follows. A lot of times when people decide to eat popcorn or potato chips or drink soda or eat chocolates, they tend to make what we call a meta decision. They decide to eat popcorn, they don't decide how much. So I'm going to open the bag, and I'm going to start eating. And I don't look at the next kernel and say, well, should I eat this one? It's tasty. Or that. I just keep going till the bag is all finished. And so what happens when I have 4 bags is something interesting, is I start with the first bag, I eat until it's all gone, and now I have an active decision to make. And that decision is, should I open the next bag? And that's where the rational part of myself kicks in, and I say, no, it's time to stop. So in sum, what happens with this experiment is that the moment you take a large resource, be it popcorn or soda or time or money, and you partition that into multiple units, you are creating what we call a decision point. Amar Chima and I did a number of experiments that tried to replicate the thought experiment that we just showed you with popcorn. We showed that when chocolate is packaged in different units, its consumption decreases. We found that when cookies are partitioned by putting glazed paper in the middle of different cookies, in fact, again, people slow down the consumption of cookies. We found results with beverages and with all kinds of foods. And we thought to ourselves that if this works for food and for beverages, might it work for other kinds of resources? So back when I lived in Hong Kong, we did an experiment at the Hong Kong University of Science and Technology. We invited a number of people to participate in a gambling study. I mean, how much fun was that? They came to the lab. They were each given 100 gambling coupons that looked like that. Each coupon had a cash value of 50 cents, which meant that every individual in our experiment was carrying about $50 worth of assets, which they could exchange for cash at any point in time. So people could actually choose to simply leave the room, cash in their 50 bucks, and be done. Of course, gambling was fun, gambling was almost addictive, and a lot of people in our experiment told us that they knew they shouldn't gamble, but they had fun doing it. And hence, our idea was to try and see if partitioning these coupons into different set sizes actually changes how much people gamble. Here's what happened. People were given coupons in one of 2 conditions. In one condition, there were 100 coupons in an envelope, sealed and given to participants. In a second condition, there were 10 coupons in an envelope, and 10 of these envelopes were given to the participant. So in every condition, everybody got 100 coupons. It's just that in one set of conditions, there were 100 in one. In the other set, there were 10 in 10. And we were interested in seeing how much people gambled as a function of this particular manipulation. The gambling exercise was fun. People had to actually go online, click on a button. There was a wheel that spun. With some probability, they won 5 coupons for every coupon that they had gambled. I believe the probability was 1 in 3. And there were only 2 rules of the gambling game. Rule number 1 was that they could not gamble away their winnings, so they could only gamble up to 100 coupons. Rule number 2, they had to gamble 1 at a time. What happened? Well, here's what happened. The panel on the top shows you the number of people who actually gambled a given number of coupons when they had 100 coupons in one envelope. So the panel on the top is for people that had all 100 in the same envelope. And what you see is a lot of people chose not to gamble. Right? So the first few bars are actually 0. Those are folks that didn't gamble at all. But boy, once they started gambling, the bars keep increasing in height. And what you'll see is that there was one person that actually gambled away all 100 of their coupons. The panel at the bottom, on the other hand, shows you conditions where, in fact, people had 10 envelopes, each with 10 gambles, with 10 coupons. And what you see there is that almost everybody gambled. There were only 2 people who chose not to gamble. But the height of the bars are now much lower. Some people gambled 20 coupons, some 30, some 40, and in fact 40 was the highest number that was gambled. And what's interesting is that these amounts gambled represent multiples of 10, which essentially means people opened an envelope and then stopped, or opened 2 and stopped, or 3 and stopped, and one person opened 4. Again, same principle. The coupons were like popcorn in bags that are different sizes. When people opened one envelope, the coupons kind of became free. There was not much thinking that went on. People consumed a lot. But in fact, when people had to multiply open a number of envelopes, that was a decision point which forced them to stop.